All right. All right. Good morning, guys. Continuing a new lesson today after yesterday's quiz, which I'll continue grading today, the division quiz. If whatever reason you missed class yesterday, shoot me an email today and we will find a time for you to make that up. Okay. So continuing factoring, this is something that you may or may not have seen in Algebra 1, I guess, depending on when you took it with kind of the disruption that we had last year and going full remote. I'm not sure if you got to this, but this is called factoring by grouping. Okay. And what kind of identifies that we're going to have to take this approach is the fact that there's 4 terms in these problems. So if you're looking at these first 6 problems, each one of them have 4 terms. Okay. So anytime the directions say factor, the first thing I do would be to ask myself if something was common throughout, the polynomial, whether it's a variable or a number. You always ask yourself, is there a GCF? Okay. None of them, in this case, will have that GCF. And each one of them, as I said, has 4 terms. So here's how you go about this method that we call grouping, right? And it's called grouping for a reason, because we're going to group a few times here. We're going to think about grouping to begin with, in that we're going to kind of divide, maybe not divide it, I should say split the problem in half, right? So I draw this line separating the first 2 and the second 2 terms, okay? And with each set of terms, so within this first set, I'm going to ask myself, is there a GCF, right? What is the GCF here? And it's x squared, right? Then I would ask myself, okay, well, what's left? What's left is a 3x minus 1, right? Quickly, oh, I'm sorry, not minus 1, minus 2. Quickly redistribute to check your work, okay? And you would catch that little mistake that I just made. But we should get what we kind of started with there, all right? And then we do the same thing with the second set of terms. I ask myself again, all right, well, what's my GCF of 24x and 16? And you would say an 8. What's left? 3x minus 2. Now, the fact that we have the same thing in each parenthesis is not coincidental. That must be the same for us to continue this method. If these were different right now, we can't continue. It would just tell us that, all right, this is just not factorable by grouping. But because they are in fact the same, we now can continue to the next step, which is to, again, group the terms that are on the outside of the parentheses together, and then just rewrite that second parenthesis or that common parenthesis one time. And that's our answer. All right, so in number 3, again, cut it in half. Think what's common just here with the first 2 terms, and it's a 3n squared, which would leave me with an n plus 6. And yeah, if you look at the second set of terms, all we see is an n plus 6, right? But you still got to ask yourself, well, what's common? What is there a GCF? And I think a lot of times, we want to try to get a number or a variable. And if this was kind of any other problem, we would probably say, all right, there's nothing common here. But in fact, there always is something common, right? And that something is 1. So we're going to take out a positive 1 here. And that would leave us with n plus 6. All right, it's just something to take note of. Whatever sign this one is, it will be the same as the term that you pull out. So again, a plus here, a plus here. When we do number 5, you'll see that this term will be negative. But again, we've got it because we've got the same parenthesis, all right? N plus 6, the same exact thing twice, which means we can continue to our next step to group what's on the outside of the parentheses and to rewrite the second parenthesis just one time. Okay? Number 5. Again, cut it in half. And it looks like a 2n squared, which would leave us with 6, not n, 6r, and minus 1, right? That placeholder. It's not 0. You got to be able to redistribute it back in and get what you started with. And like I said, if this term is negative, we're going to take out a negative. All right, our GCF here will be negative, and it's going to be negative 7. And we should know that anytime we take out a negative, the signs of what we have remaining are going to change. So it's going to be 6r, and it's going to be a minus 1, right? Redistribute, check your work, negative 42r, positive 7, we're good. And again, same parenthesis, so we can continue. And that would be our final answer. All right. And look, if you have time or you're just unsure of how that works, remember what factors are. They're the terms that multiply to give you the original term. So if I were to FOIL this, I'd get 12r cubed, right? I'd get negative 2r squared minus 42r plus 7. Exactly what we started with. All right. The next few problems, okay, involve something different. So the first 6 are all factoring by grouping. The bottom 6 here are what's called sum and difference of cubes. So you need to either pause the video or just make sure you have these written down. But for lack of a better word, these are formulas. These are how you factor the sum and the difference of cubes. All right, there's a pattern to these. And you'll notice it's very much the same thing, except for a difference in signs, okay? But just like we have factored a difference of squares in the past, okay? You have 2 terms, both of which, oh, thank you, Lev. Thanks. You brought me my water? Thank you. Both of which, in this case, are perfect cubes, right? And there's a reason why you see 8, 27, 64, 125 repeated here, because 2 cubed, 3 cubed, 4 cubed, 5 cubed. They're the numbers that you have to work with in order to be able to do this. You're not just going to see some totally random number here. So think of the cube root of each, right? And if you want to assign A equals and B equals, that works. Like, so A equals X and B would be 5, right? I've seen students do that each year. And then they kind of go into the formula here and they substitute them in. But where I got those numbers were because they were the cube root of each. So if I want to now go to my formula, it would be X plus 5, right? Then I have to square X. Then I multiply the 2 together. Then I square 5. And that's your answer. That's how that factors, believe it or not. All right, so the same thing here. Figure out that first parenthesis. What number or variable multiplied 3 times would give you A cubed? And that's where we get just A. What number multiplied by itself 3 times gives you 8? Well, 2 times 2 times 2, or 2 cubed. All right. And now because it's the difference, we would have to follow this setup, which just means, again, just slightly different signs. But it's A squared, multiply these 2 together, plus 2A, and square the last term, so square 2. And that's how you would do that one. All right, so I'm kind of jumping around a little bit here. Actually, let's do number 9. And then that'll be the final one, okay? So anytime the first term of something is a negative, whether it's the cubes, grouping, squares, I would recommend factoring out the negative first. So let's just take out that negative and let's worry about this, okay? So not much of a difference other than it's now an 8m cubed. It's not just m cubed, right? But again, 8, 27, 125. There's a reason why we're seeing repeated numbers here. So the cube root of this would be 2m, right? Because 2m cubed would give us 8m cubed. Plus 3. 3 cubed is 27. So now go back to this, right? Square the first term. But a common mistake here, students just make it 2m squared. But the first term is 2m, and you have to square it, which means you have to square the 2 as well. Multiply the 2 together and square the last term. So I think once you identify that first parenthesis, and by us kind of doing these 3 problems and working with the same numbers that you're going to see in the next 3, I think you'll be confident with it. All right. So take notes on these, watch the video, and then later tonight, for homework or whatever you have time this afternoon, I'm going to ask you to complete this first page. All right. So to complete problems, 1 through 12 that we did not do. So I think that's 2, 4, and 6, and 10, 11, and 12. All right, guys, enjoy your snow day, and I will talk to you later. If anyone has any questions, just shoot me a quick email. All right, thanks.